Assalamualaikum, my name is Syahirah Binti Mohd Shamsul from AS2016A. I'm here to present my final year project entitled Phytochemical Screening and Antibacterial Activity of Ginger Zingiber officinale Rhizome. This research was supervised by Ms. Nur Tabitah Binti Shaikh Nasir. Ginger or Zingiber officinale from genus Zingiber is the semi-woody perennial herbal plant that is commonly used as spice in dishes of many countries. Aside from being food flavoring agent, ginger is also well known for its therapeutic and healing effects. Ginger possesses antioxidants, anti-inflammatory, antimicrobial, anti-emetic, anti-cancer and anti-tumor properties which make ginger useful in treating a wide range of diseases. Therefore, ginger has been used traditionally to treat a wide range of illnesses such as cold, fever, gastritis, and diabetes. The therapeutic value contained in ginger are mostly contributed by the presence of phytochemicals such as alkaloid, flavonoids, tannins, saponins, phenols, and many more. In many years, numerous research has been conducted on various plants for the development of medicine as an alternative to the synthetic ingredient used in medicine. Antibiotics are one of the medicines that have evolved synthetically. However, antibiotics tend to be overly used or wrongly prescribed, resulting in the rapid development of antibiotic resistance where the effectiveness of the antibiotic are interrupted. Therefore, plants are used widely in the production of pharmaceutical products such as antibiotics to develop plant-based antibiotics that are able to overcome the matter and can treat common to deadly illnesses. This study allows a broad exposure of medicinal value contained in ginger to other people. The role of ginger should not be overlooked and limited as a flavoring agent only, but also its medicinal value can be gained by the society to improve their well-being. This study opens the opportunity in the development of antibiotics to overcome antibiotic resistance due to the antibacterial properties possessed by ginger. The objective of this study is to investigate the antibacterial activity of ginger rhizome extract on gram-positive and gram-negative bacteria. In addition, this research was also intended to determine the phytochemicals present in ginger rhizome through phytochemical screening. And 2018 reported that ginger has been used as herbal medicine for 5,000 years in China and India to cure a wide range of illnesses. Zivapur et al. 2021 reported that ginger able to cure cold, fever, coughs, nausea, diarrhea, and even diabetes. The therapeutic value of ginger is largely contributed by the presence of phytochemicals. According to Kela et al. 2022, phytochemicals that are identified in ginger include alkaloids, flavonoids, saponins, tannins, glycosides, phenols, oxalates, and anthraquinone. Based on research by Yan et al. 2021, Yuan et al. 2021, and Rahmani et al. 2014, phytochemicals that contribute to the antibacterial properties of ginger include alkaloids, flavonoids, and phenols. Ginger possesses a potent antibacterial activity. According to Sabra et al. 2014, the antibacterial properties of ginger are largely contributed by the presence of phytochemicals that have the ability to prevent stomach infection by inhibiting the multiplication of Escherichia coli and Staphylococcus aureus. This research required the preparation of ginger extract from two types of solvents, which were ethanol as polar solvent and chloroform as non-polar solvent. Phytochemical screening was conducted to observe the presence of alkaloids, flavonoids, tannins, saponins, and phenols. Next is preparation of nutrient broth. In this research, 2.8 gram of nutrient powder was used to dissolve in 100 ml distilled water. Next is the cultivation of bacteria in the nutrient broth. This research used two types of bacteria, Bacillus subtilis as gram-positive bacteria and Escherichia coli as gram-negative bacteria. The preparation of agar media, Mueller-Hinton agar powder was used in this research. McFarland standard was also prepared for this study to standardize the number of bacteria. Next is culturing the bacteria on the agar media. Kirby-Bewer disk diffusion test was conducted instantly after the bacteria cultivation step. The positive control used in this study was the antibiotic ampicillin. Meanwhile, the negative control used were the solvent, which were ethanol and chloroform only. The diameter of zone of inhibition were measured after 3 days of incubation. Data analysis was conducted using SPSS, and two-way ANOVA was used to see if the mean inhibition is influenced by other variables. As the result for phytochemical tests, the test for alkaloids showed positive results for both extracts. This is because reddish-brown precipitate was instantly formed after Wagner's reagent were added into the extract. The test of flavonoids also indicated positive for both extracts. However, chloroform extract indicated an obvious color change as the strong yellow coloration turned into colorless. Meanwhile, ethanol extract only showed a small change, where the strong yellow color changed into translucent yellowish mixture, which probably indicated traces amount of flavonoids. Tannins were also detected in both extracts through the appearance of brownish-green coloration. Chloroform ginger rhizome extract was appeared to be more yellowish color. Saponins were detected positive in both extracts, as the addition of olive oil into the mixture of extract with water turned the mixture into milky solution. Lastly, a phenol test indicated positive results through the appearance of green coloration in both extracts. The finding of this research found that ethanol ginger rhizome extract at the minimum inhibitory concentration MIC of 400 mg per ml has the highest mean inhibition zone to be compared with other concentrations against Bacillus subtilis and Escherichia coli, which were 1.00 plus minus 0.0 cm and 1.53 plus minus 0.15 cm respectively. 200 mg per ml of the concentration of ethanol ginger extract was revealed to have the lowest value of mean inhibition zone for both bacteria. Based on the statistical analysis, the concentration of 800 mg per ml showed the highest value of non-significance with P equal to 0.98. In addition, all three concentrations have p-value more than 0.05 compared with ampicillin. It means that ethanol ginger rhizome extract are not statistically significant and can be interpreted that the extract has the same effectiveness as ampicillin. The overall mean inhibition zone by all concentrations was significantly higher than the negative control, in which the mean between non-control group and negative control are statistically significant, which is p-value is less than 0.05. The zone of inhibition of the negative control was probably due to the ethanol alone is widely used as antiseptic and disinfectant to reduce the spread of bacteria and viruses. On the other hand, chloroform ginger rhizome extract at the minimum inhibitory concentration of 800 mg per ml has the highest mean of zone of inhibition compared with other concentrations against Bacillus subtilis and Escherichia coli, which were 1.73 plus minus 0.06 cm and 1.67 plus minus 0.19 cm respectively. The lowest concentration, 200 mg per ml, has the lowest mean of inhibition zone at 1.47 plus minus 0.60 cm against Bacillus subtilis and 1.48 plus minus 0.19 cm against Escherichia coli. 200 mg per ml and 400 mg per ml of chloroform extract were not significant to ampicillin with p-value are greater than 0.05 and can be interpreted that this concentration have the same effectiveness as ampicillin. Meanwhile, 800 mg per ml was statistically significant with p-value equal to 0.01. This was probably due to the mean inhibition zone of the concentration that was higher than ampicillin. This emphasizes that 800 mg per ml of chloroform ginger rhizome extract possess a great antibacterial effectiveness than ampicillin. The increasing mean of inhibition zone, accordingly to the concentrations, verified the study by Rawal and Adhikari in 2016 that revealed the effectiveness of chloroform extract increased with concentration. As you can see in the raw data here, the diameter of the inhibition zone for positive control ampicillin is not great as the non-control group. This is because according to Bubonja Sonje in 2020, the effectiveness of ampicillin might be reduced due to several factors such as insufficient concentration for antibacterial activity, long duration of exposure, and unsuitable pH and temperature. In addition, both bacteria showed sensitivity towards chloroform, the negative control used in this study. This is because according to Regada 2013, Chloroform was reported to be capable of disrupting the bacterial cell membrane and inhibiting the bacterial metabolic processes. Based on the findings, it was also found that Escherichia coli were more susceptible than Bacillus subtilis. The susceptibility of gram-negative bacteria towards the extract was unexpected because gram-negative bacteria are known for being more resistant to antibacterial agent than gram-positive bacteria. This is due to the presence of peptidoglycan and outer membrane that composed of lipopolysaccharide, lipoproteins, and periplasmic membrane. The lack of outer membrane in gram-positive bacteria caused the bacteria to be inhibited more easily than gram-negative bacteria. However, according to Silaban in 2021, several factors such as bacterial concentration, extract stabilization, and extract diffusion ability might have influenced the bacterial activity of Escherichia coli. To summarize, ethanol ginger rhizome extract and chloroform ginger rhizome extract showed the presence of all phytochemicals. The presence of all phytochemicals in the extracts supports the findings by Kela et al. In 2022 that phytochemicals identified in ginger are alkaloids, flavonoids, saponins, tannins, and phenols. In addition, the finding of this research that have confirmed the presence of alkaloids, flavonoids, and phenols also verified the findings by Buffo and Karaman 2019, Yuan et al. 2021, and Ismawati 2022 that these phytochemicals strongly contributed to the inhibitory activity of ginger extract against the growth of bacteria. As a conclusion, ethanol ginger rhizome extract and chloroform ginger rhizome extract possess antibacterial effect against gram-positive and gram-negative bacteria that's shown by the presence of inhibition zone, with the concentrations become one of the factors to the diameter of the inhibition zone. The polarity of the solvents possess an influence towards the effectiveness of the antibacterial activity against Bacillus subtilis and Escherichia coli. Chloroform ginger rhizome extract was found to be a better solvent to extract the phytochemicals contained in ginger than ethanol. The presence of phytochemicals influences the antibacterial activity of ginger extract. All in all, ginger can be the new source of curative compounds that can pave the way for the development of antibiotics, which can contribute to the well-being of the society. As for recommendations, extensive research on the factors that affect the susceptibility of gram-negative bacteria towards antibacterial agents should be conducted to overcome the challenges in antibiotics resistance. Secondly, a study on the influence on the solvent's polarity towards the ability to extract phytochemicals contained in the plant materials should be conducted. Lastly, further research should be conducted on a wide range of solvents that come from different polarity to identify the best solvent in ginger extraction for the development of antibiotics so that the medicinal value of ginger can be fully utilized for the welfare of the society. Thank you for listening. Goodbye and Assalamualaikum.